So this project started as a way to pick out the parts that each concentration is really good at. So including metalwork and jewelry, doing that fine detailed work, the small scale metal casting, industrial design, experience with design and 3D modeling, and then sculpture, incorporating some of these larger processes and an expertise in the foundry area. But personally, just trying to see if we can make this happen between 6 different students from different concentrations and 3 faculty in a limited time frame.
After we recruited some students, Dan, Emily, and myself wanted to oversee but not control the project. We wanted the students to really truly have the ability to work with each other. So we started a few weeks of just kind of group brainstorming sessions. What could this be?
The students spent a lot of time generating ideas, different drawings, some like brainstorming diagrams.
We started with very large format and started to work with what was realistic in terms of the materials.
Sculptors, we like to work large, and metals and jewelry, they tend to work more in a very intimate size. So we were thinking that this could be an extremely large piece, but then quickly realized that we needed to scale back down some. But we didn't want to scale back down to this intimate part, we wanted to grow it further. So I think that's what our sculptor students brought to the table. For this project, something that was really important for us was to talk about this dialogue between old processes and new processes. So combining digital technology, so printing these objects and casting them into aluminum, which is a very old traditional methodology for sculptors to work with.
Once they decided on what imagery they would use, they then figured out what would be the best way to make that.
So my role in the project was to help the students with the digital aspect of creation of 3D objects. After we had kind of an idea of what we wanted to do, we started working with collection of objects, whether they were found objects in nature or whether they were built digitally or even found online. The piece that we're trying to make really has a nice juxtaposition between those natural organic elements and those very rigid elements, and the 3D printing as well as the 3D modeling were able to produce those. The method of 3D printing or the act of 3D printing, you'll go onto the computer and you will develop a 3-dimensional object using any kind of 3-dimensional building software. For us, we work with surfaces in a program called Rhino. The 3D printer program converts it into data that this machine will then be able to translate. And so a 3D printer will take any kind of 3-dimensional piece and it'll break it into very thin lines, 2 to 6 thousandths of an inch. Those are called cross sections. It's got a build plate and it's got a nozzle. The nozzle will go back and forth and left and right, and then it's got a build plate that will move up and down. The 3-dimensional piece will then be broken into those layers, like I said, and it'll do X and Y, so left and right, back and forth, and then it'll drop down and do the next layer.
For each piece is a different time frame. Like the big base actually took about 24 hours for the 3D printer to make. Some of the smaller sections would maybe take 3 or 4 hours to print.
We had some interesting trials and tribulations with the difference between inches and millimeters. We'd bring something in and we wouldn't see it, and we would think that it wouldn't be there because it was microscopic. So that was a fun challenge. Scale was something that we really had to focus on and try, and we did find during the process that things would either not 3D print right or they wouldn't cast right. And the wonderful thing is we already had those files and we could easily 3D print those things as needed. It was a process that you weren't reinventing the wheel. You weren't starting from scratch every time.
With this project, primarily we've been doing casting and fabrication, the small-scale glossed wax casting process.
After the object is printed, we will sprue and gate that up. So what that looks like is if you have this object here, then we'll create this sort of tree that the metal can flow down into. And then at that point, we can take it and put it into an investment.
Investment, which is like a plaster mold. The object is made in wax or wood, something that gets burnt out so that there's this negative space in the mold. We then hold it at a certain temperature so that when we pour molten metal into the mold, it'll fill all of those areas. We quench it while it's still hot, and by quenching it in water, that investment cracks and falls out of the mold, leaving your actual metal cast object in the flask. With our sculpture, we have the tree section, and it was decided that to 3D model a tree would be so much more complicated than actually taking branches and doing life casting, so burning out the wood and pouring directly into the mold. Versus other objects like the crane, which is geometric, it has more negative spaces, things that would be harder to fabricate by hand. Those were all 3D modeled.
We've had a couple of casts not fill correctly. With printing, you can print a small part and see what's happening with it, and if it's not working out, you can stop it. But with casting, you have to complete the whole process to find out what it is that you have. With the ones that have failed, we've not melted enough metal, or we haven't gated them correctly. Maybe our sprues are a little too small. And so we have to make adjustments for the next piece, which means we have to print more or the corrected piece that we just casted.
The investment that is in all of the tiny crevices that hasn't gotten shocked out when it was quenched, all of that needs to be cleaned, scrubbed, which would leave a half-finished, semi-cleaned up aluminum casting.
So once all of the pieces are cast and we've taken them out of their molds, the next process for that would be to cut them all off their sprues and their gates, and then we start what's called chasing. And that is cleaning up any areas where that gate hit the object. And because once we cut it off, it's going to be this new, fresh, cleanly cut metal that doesn't match the textures and the qualities that the object has. So we'll take chisels, files, and other instruments to get that texture back into it. Now, some of these parts, because we're casting lots of them, multiple pieces, we have to be able to actually put them back together again. We'll go back with our TIG welder and weld back over, or weld all these parts together so that they will be permanent. Once that happens, again, we have to go back and chase all of those welds and connections to make them uniform and match the rest of the object. As soon as we have everything connected, then we can go on to finishing. So aluminum, it's a very nice material for sculptors especially because it doesn't corrode like steel does. It does oxidize, but it's not as noticeable. Great for enduring weather.
What I hope that my industrial design students, and as well as myself in my teaching, want to gain from this is the evolutionary and organic process of coming to a final idea.
What we really wanted from the start was to give the students an opportunity to expand beyond their concentration and get a glimpse into these other medias and how, in reality, they can all interact.
In the professional world, you're never going to be working solely with just one mindset and one type of individual. And so giving them the opportunity to collaborate, especially with people from different disciplines, listen to what other people say, take criticism, offer valid and valuable criticism, as well as really work together in a group to find the idea or the project deliverable that everybody is satisfied with.
Collaboration is great just as us as faculty because I don't get to talk to ID. I don't get to collaborate with you outside of this project or during class time, and so it's important for me to see what's happening out there in the field and how I can bring that into my classroom.
While you're in school here at UL, you've got this 4-year period to just hone your skills in one concentration, but they really do expand beyond that. And I think the students got to see that and had a brief encounter with that process.